Site-scale projects, like remediation design, construction dewatering, and drainage planning, all rely on groundwater models to test ideas before implementation. But these models need to be practical. They must work with limited data, adapt to changing project conditions, and provide useful insights quickly. The challenge isn't just building a model, it's designing the right model for the job. If you've worked on site-scale projects, you know the pain points. Most of the time, you only have data on the saturated thickness of the aquifer at your site. The local groundwater flow direction, that's inferred from a few wells. Local geological conditions. They're shallow, pieced together in phases, with boundary conditions beyond the site often uncertain. And let's not forget, real-world groundwater flow doesn't always follow a textbook pattern. Man-made structures, infiltration variations, and unknown discharge points complicate things. The reality is, you often don't have the data to fully define how the groundwater system works beyond the site. And guess what? That's okay. Here's the key takeaway. Site-scale models are best for site-scale projects. You don't need a regional-scale groundwater model to solve a site-specific problem. Instead, you need a model that works with the data you have, one that's fast, flexible, and focused on what matters most, predicting how your design will interact with groundwater at your site. This is where site-scale models come in. They're designed to capture only the relevant details about groundwater flow at your site, without trying to simulate the entire groundwater system. They focus on predicting how a design, like a dewatering system or a remediation plan, will impact the groundwater using the best available data. And that's what makes them powerful. When a site-scale model is built with a specific purpose in mind, it can answer exactly the right questions, helping you make informed decisions quickly and efficiently. So how do we build site-scale models efficiently? That's where Anaqsim comes in. It's designed for fast and flexible groundwater modeling, perfect for site-scale projects. Now, site-scale models are often called cube models because historically they've been built using simple box-shaped domains. But in Anaqsim, we use something even better, the HSEG generator. It automatically creates a circular domain, defining boundaries with just a few inputs, including the groundwater gradient, flow direction, and domain radius. The result is a streamlined model setup that lets you focus on what really matters, your site. But why circular? Well, in the past, models were often rectangular because that's what worked best for grid-based models like ModFlow. But Anaqsim isn't grid-based, and circular domains actually provide more efficient calculations. In reality, neither shape is right. We just use them to simplify our models, while keeping the boundaries far enough away from the site so they don't interfere with our results. For our site-scale modeling tutorials, we'll be using these circular domains with the HSEG generator. But don't worry, if you love box-shaped models, I'll show you how to create those in later videos. So, if you're working on a site-scale project, remember this. Site-scale models are the right tool for the job. And with Anaqsim, building them is fast, easy, and flexible. In the next tutorial, we'll start building our first site-scale model using the HSEG generator. I'll see you there.